Here we are, exercise 4. And this one, we're going to learn to use the debugger. So our plan is we're going to learn to use GDB. GDB is a debugger that works on Linux. I believe it's with Cygwin 2. LLDB is what's on OS 10. We're also going to play with something called Valgrind. So Valgrind is cool, but it doesn't work on OS 10. So we're just going to run Valgrind on Linux so you can see what it does. And if you want to try and use it, you can use that. There's a newer tool called AddressSanitizer that I won't get into in this video, but I will have a freely available, more extensive video on just debugging C code. I think that's going to be something that I'm just going to have freely out there. That's just a free exercise on debugging. So if you can't figure out the tools on your own, like how to get Address Sanitizer work in GDB, look at that video. Then we're going to cover the quick reference that comes with the book, and then I'm going to debug a program. So what is a debugger? So a debugger is pretty simple. If you're from languages like Python or Ruby and you're not used to using an IDE, it's the thing that lets you set breakpoints and look at values and variables and stuff. But the difference is on a computer, you can actually, when it crashes, it'll stop and it'll give you back traces and tell you where things blew up, which is really helpful in C. We're going to be doing a lot of breaking things. So in my book, I say use the debugger. But when I say the debugger, I mean everything. Use GDB, use Valgrind, use Address Sanitizer, use Lint, use anything to get your hands on. So I'm going to show you how to do that really quick, and then you can go to the more extensive video later if you need to. So this is my Linux machine, and this is my local machine. So what I have here is on OS 10, my local machine, you have LLDB, and it's just a shell. It basically is a shell for running your programs under the debugger. So the debugger observes your program executing and then lets you make stops and do things. On Linux, it's GDB. So nearly the same thing, but a lot more boilerplate when it starts up. So what ends up happening is they work the same, but they have different commands. So I'm going to go through GDB, but I have a quick reference in the book for both of them. GDB. So when you run GDB, I can go like this. Right now, I'm just going to use the exercise 3 code as an example. But if I do GDB EX3, that loads it up. And then I can do run, and it'll run it. It's pretty straightforward. If there were errors, it would stop at where the error was. Like if there was like a memory access that caused a seg fault, it would stop. And then you could do BT to get a stack trace. But there's really no stack trace in this right now. So what we have now is there's certain commands I can use to debug it. I can do what's called breakpoints, and that breaks at the main function. So remembering the code from exercise 3, that's line 3 right there. And then I can say run, but we have a slight problem. When I get to this, I want to be able to do lists to see where the code is. Like it'll list out where I'm at in the code in case I'm lost, but I don't have any debugging symbols. I compiled this with the wrong thing. So I'm going to quit. And what I'm going to do, I'm going to remove this. And remember, I can do C flags just, on an emergency basis, but you should already have this. I can do WAL-G. And I'm sort of showing you, like, if you had to go onto a Linux computer and debug something, this is how you would do it. Oh. Now it's compiled with the debugging symbols. -G means give it debugging symbols. Don't ask me why G gives you debugging symbols, but that's what it is. Now when I rerun GDB, I can do break main again. Oops, break main, run. And now I get source code. So it shows me what line I'm at. That's what that -G option that you set in your makefile does for you. It gives you line numbers where things happen. If I do backtrace now, BT is for backtrace, it shows I'm just in that function. So I can actually do step, that gets me to that line. Step, that gets me to that line. See how it's printing that in? Step, I believe, should go into the printf. Yes, it's in the printf. Now if I do BT, I'm in main and then printf and so on and so forth. I can do step again, and I'm now in printf.c. I do BT again. I'm in even 4 levels deep, 3 levels, 2 levels deep right there. So this is what this does. And then I can do next and next. This will get me out of it. I can do continue, and that exits. So that's your crash course in running GDB. Now, here's the thing. That's useful when you want to get in there and sort of like quickly find out why something's not working right. You can print out variables, you can look at stuff. All of this is covered in the quick reference. But one of the useful things that you want to be able to do is you want to be able to run this command that I give in the examples there. It's a useful command, and I have it in here already. Okay, what this tells GDB to do is run this program, ex3, under GDB with all the options and printing out stack traces and back traces if things exit. So it's sort of like giving you a supervisor of it. So when I run it like this, fine, there's no stack trace. So if I wanted to cause it to make an error, let me just see if I can do that. Let's see if we can get, yeah, here, I'm going to try and do something really bad. You don't even know what that is, but let's see if I can make it crash. And make it run. So it's giving me all these warnings. Again, remember, warnings are just bad for you. And then I'll rerun that GDB. And yep, got to there, but it didn't really crash or anything like that. So it printed out the one and then the other, so printf didn't do it. And again, remember, sometimes it's hard to make C code just crash. It's just, yeah, I mean, it crashed, it did bad stuff, but you know, it's not really doing anything. Let's see if we can do something else. Let's see. I'll try one more thing. Oh, and actually, I'm going to do something really fun. Void. This is how you make a function in C. So I'm just gonna make some really bad code. Something really heinous. And I'm going to print out every character like this. This is very, very bad code. Do not do this. I'm making bad code on purpose so you can see what I'm doing. Okay, that looks okay. Let's compile it just to see. Oh, and I want to use my C flags. All right, unused variable, that's fine. We're trying to make it crash on purpose. Still can't make, oh, I have to call the function. Let me just do that next. It's actually instructional to try to make bad code on purpose. So let's see, let's do crash. You know what? Just in case, let's call it a whole bunch of times. That'll do it. Oh, and then make it. There we go. So this is what happens when you do super bad things. And when you get this sigsegv, right, just run this GDB command. If you were really fancy, you would make yourself a little alias. So you just like, you know, like call it GDB super or something like that. And it runs it, but notice it runs it and then you get a stack trace. And it shows you main at line 18 and then ex3 at line 8. So if I do those, you can see ex3.c, and that's right there at this line here for the printf. So there you go. That's like the most useful command for doing C code. This is pretty much an alternative. It's a very lame alternative to Valgrind, but this will help you a lot. For the rest of it, you want to go through this quick reference and keep it around. This quick reference will tell you all the different stuff and give you a good introduction to it. And remember, I'm going to have another video that's more freely available for everyone because this seems to be a very common thing. So this one's to get you started on GDB so you can continue the book. LLDB. So LLDB is almost exactly the same thing. And I'm just going to quickly go into here. And again, I believe in this directory, yeah, I have ex4. Same kind of thing. Run ex4. Oh, let me just do it this way. It's easier to just do that. And then do run. And there you go. Nothing big. Remember, the commands, they have the same commands in LLDB. It's just that they're just different to be different. There's no other reason. So what you have is you can have your backtrace. You need to say thread backtrace. You can print expressions like you did in GDB. You can do just about anything. You can do breakpoint set, and you can say what function you want it in. So for example, I could do this. I could say, here, we're going to do breakpoint. I'm going to say main. All right, so that's the command compared to GDB for running main. Now, I'll say run, okay, and it's showing me assembly code, which is just weird, but okay, there we go. That's what assembler looks like. And then what I'm going to do is I'm going to print an expression. Now, in GDB, you had the same capability, and it's pretty much the same. It's the same thing. So at that stack point, I believe, let's do step, and then do print age. No. Oh, actually what we got to do, same thing, ex4 c flags equals -g. All right, so then once we have that LLDB, we can do our breakpoint at main. We can do run. Yes, now we can. That's why it was printing out the assembler. So if you see this, looks like really strange code. This is actually assembly code. It's very cool. Then you didn't compile it with -g. If you're using the makefile, you don't have these problems. So I'm right there, so I can do next, and then I can do print age, and that prints out age. Over in GDB, I had the same capability. So let me just do that real quick just to show you the difference. Believe had it. Oh, I did a lot of that. I'll just do GDB ex3 break main run step print age. Oh, print age, and there we go. Same concept. Everything is pretty much the same. It's just the commands are different. So that's LLDB. Now remember, what you should be doing is messing around with these commands. You should be able to learn these new commands and these things. So just sit down and go through it. Next up, I'm going to use Valgrind. So Valgrind, I have that broken program that I made on my Linux computer. So Valgrind is a really great tool. It's basically that command that we ran that did this and gave us that stack trace. Valgrind does the same deal. And there's lots of options to Valgrind, but I'm just going to run it super quick and see what it does by default with that super broken program. And so notice it does nearly the same thing. It says it had a crash here and it had a crash 8. That's the same as the GDB backtrace that we did. The advantage Valgrind has, though, is it will track memory releases. We'll get into more of this later. And the reason why I'm not covering Valgrind so much now is the only way for me to explain Valgrind, you have to know how the heap works, which is something we cover later. So I can't really get into it right now. But what Valgrind will do is it'll track all of your memory and it will tell you when you've messed it up. That's super handy because it's like one of the #1 mistakes you make. And one of the hardest things to track is memory management in C. So with Valgrind, it'll help you. But you don't have Valgrind on OS X, so this is a good proxy command for the same thing. And honestly, it's kind of a better command when you have seg faults, so that'll help you out. Valgrind will give you a few better errors and richer errors and better stack traces, but they all depend on the -g option to GCC. All right, next one is using Lint. So Lint is pretty simple. There's a program called Splint. It basically goes through and it checks your C code in a static way, and it just prints out bad things to look at. So for example, it's not running the code, so it can't tell you if it's exactly right, but it says index of null pointer test is possible, in function name, a variable age declared but not used, function exported, And then you've got, yeah, basically it's telling me a lot of bad stuff about that file, which is on purpose. We made those bad things. So to find that, you're basically going to go to Splint, look for Splint. Lint. And this is its home page. There's a whole bunch of other programs. Just look for the concept. It's a Lint. A linter program. Lint was the first one. A Splint is a good one. You have to do some weird stuff to compile it on OS X, but otherwise, if you're using Homebrew or something, it should compile no problem. So, AddressSanitizer is a little bit of an advanced topic, but it's sort of a new alternative to Valgrind that should work on OS X because OS X uses clang. So what I would say is if you want better memory checking and you're on Linux, use Valgrind. If you're on OS X, try out AddressSanitizer. I'm not going to get into it now because, again, I have to cover heaps and memory management before I can explain what this thing does. So there will be another video that you'll be able to go through. But try this out. See what it does on OS X. Try it on Linux. Maybe it's better than Valgrind. A lot of people seem to like it. It has advantages and disadvantages. If you're on Windows, it might work. I wouldn't hold your breath, though. So just use GDB and, like I said, try out Linux. So that's AddressSanitizer. I'm not going to get into it in this video because it's supposed to be a short introduction to the tools you need to use, which is GDB or LLDB. So the reason why I had to sort of cover this is one of the things is you've got to break stuff. And in order to break, the reason why you're breaking it is to see what happens. You can't really wreck your computer these days. It used to be you could wreck your computer doing these kinds of things on the older computers, but now you're pretty good. So what you want to do, run stuff under Debugger. Do what I did. Make bad code. Make it just crash. See what you can try and do. When you see the code that's in this exercise, you'll see the bad code that I have, and you'll understand what I mean when I say you try to make some bad code. It's not that hard to make it crash. That's the end of Lecture 4. I'll see you at Lecture 5. At this point, you should be able to compile programs, type in some basic C code. You kind of know how printing works. You know how makefiles work for building your files, cleaning things up, and you've learned how to run a debugger. So now we can start the business of really hunkering down and learning C. And what I'm going to teach you is the fastest way I know to teach someone a programming language. I think you're going to like it.